Another really super duper important part about your body is for the electrolyte balance, is trying to make certain your acid and bases are fine. If you go too high or too low, you get too acidic and too basic, you've got issues, and life is not going to be happy for you. Let's go ahead and talk about pH and what it means. If you are around 7 or in the 7 point whatever index, you are considered neutral. If you're below that, you're acidic, meaning that you have too many hydrogen ions of H+, or if you are too basic, not only is your personality probably bad, okay, it's probably not that. It's more along the lines of you having too little hydrogen ions and too many hydroxide ions, but potentially. So your blood should be 7.35 to 7.45. If you're going below 7.35, it's called acidosis. If you're going above 7.5, alkalosis. You kind of see where they're coming from here. Acidosis, acid, below a specific pH is an acid, while going above a certain pH that's considered neutral for your body is alkaline or basic. I love it when they make things easy, huh? So there's a lot of ways that we can try and maintain it. There's an internal one, which is the buffer system, or where there's a certain point that we need to sort of excrete the extra stuff, so we can exhale it as carbon dioxide, or we can just pee it out. So buffer system. Buffer system is probably the one concept that's going to leak over from chemistry that you're going, oh no, why? A buffer system is just a way to maintain a pH within a specific range, even though you're getting thrown, a whole bunch of hydrogens getting thrown at you, or a whole bunch of hydroxide ions being thrown at you. So for instance, if you're getting a whole bunch of hydrogen ions getting thrown at you, then you can maintain your pH even though it's being hit really hard. Or if you are losing hydrogen ions like crazy, you're throwing up or what have you, it can maintain that pH range even though you're losing tons or gaining tons of hydrogen ions. That's a huge bonus. Can you imagine what would happen if you just said, hey, I'm going to drink some Gatorade, and you drink, then it's full of hydrogen ions, all that good stuff, and salts, that it would just shoot down your pH? That's a no-go. That's a no bueno. A lot of your proteins, a lot of those things need that pH to be just right. If you don't, then you're going to lose a lot of your functions of your proteins, your diffusions, your transport proteins, your carrier proteins in your blood. It's just not a good situation if your pH is out of whack. Now you'll notice that I did use the H2CO3 and HCO3 as an example, because that one should be pretty familiar. As the one that you saw when you were breathing out, and the majority of your carbon dioxide carbon dioxide molecules are excreted or have to be transported as HCO3 in your blood in order to get it out. Very small percentage of it, about 20%, is actually carried out using hemoglobin. So both of these should be somewhat familiar with you. The hemoglobin being the one that's carrying oxygen, and it can hold on to, surprisingly, it can hold on to hydrogens as well. Well, the bicarbonate ions is the combination of water and CO2 to make a bicarbonate. There are a couple of other ones that are a little bit less familiar, and they've been introduced into this chapter and this chapter only so far, and that is the protein buffer system, which actually, if you remember, your proteins have a carboxylic acid group that can receive or donate protons themselves, as well as you could have a phosphate solution, which can receive or donate hydrogen ions. So really quick, carbonic acid is a fantastic buffer system. It's used a lot. It is the one that happens both inside and outside of your cells. Your goal of this thing is to make certain that, again, it's 7.35 to 7.45. If you have excess hydrogen ions, it's going to make that bicarbonate ion into a carbonic acid. If you have too little hydrogens, it's going to become a carbonate ion. All of which sort of helps balance it out. But you are focusing right here with your blood. Down here, you're looking more of the basic type of solutions. Over here, you're looking at the more acidic, which is 7.25-ish range. So these guys both are important, not only in exchange of carbon dioxide, but also maintaining that balance and that buffer. It's a really a nice little hand-in-hand type of thing with your lungs and your buffers. Protein buffers, kind of mentioned it already. You got the carbonic acid that works with it, but you could also have the ammonia, and the ammonia accepting or rejecting that hydrogen ion. So phosphate, this is the stuff that's on the inside of your cells for the majority of the time. It does and accepts those protons if it needs to, or if it's too basic, it can donate some of those protons to help neutralize that hydroxide ion. Now, we talked about the stuff that helps maintain your pH in your blood, but to a point, you keep on generating hydrogen ions, you keep on generating that carboxylic, or that acid, because you keep on producing CO2, because that's just cellular respiration. So you got to figure out a way to get rid of it. And there's two ways. You could do it via lungs, or you could do it via urine. We're going to go ahead and talk about lungs really quick. Lungs, again, CO2 and H2O are pretty neutral. So H2O is pretty darn neutral. But if they combine together because of a little enzyme that's hanging out in your blood cells, it's going to convert it into a carbonic acid, which is a lot easier to transfer, but not so easy on your system if you keep on building too much of it. Bonus is, a lot of the time, once you hit your lungs, that stuff is reconverted back into CO2, and that CO2 goes away, and you're left with neutral water. Again, a lot of the things that you are going to be looking at, or that is maintaining your pH, is your breathing bodies, your hypothalamus, all that wonderfulness, as well as some chemoreceptors in your carotid bodies. Now, in your kidneys, though, there's a couple of places that sort of maintain the bubbliness. Remember that the distal convoluted tubule is your refinery. It makes that distillery. It checks for protons, it checks or reabsorbs depending on the pH of your blood, and then excretes out that frothy yellow not so goodness in this case. So it excretes protons, a lot of protons, often and frequently. And that does it by doing that carboxylic acid anhydrase that I kind of alluded to back in the blood, in the hemoglobin. That's also happening in the distal convoluted tubule and close to the collecting ducts, where it actually creates and combines H2O and CO2 and knocks out that hydrogen ion out into your urine, but it sure does leave the carbonic acid, the bicarb, in the place that you don't want it to be so much. But it does its job in maintaining its pH. The stuff inside the lumen, the phosphate, is the one that you're excreting, as well as the ammonia that you're excreting, really does do a good job at accepting those hydrogen ions and making certain that it stays in there. It's that sort of buffer system in the urine that maintains it. Again, make certain that you are very familiar with the acidosis alkalosis. Acidosis being below your blood pH and alkalosis being above your blood pH that you want. Now, we're going to get a little bit more interesting. We're going to spice up our lives right here. Respiratory acidosis is when the blood pH drops due to excessive retention of CO2, like you're not breathing very well. So now you have all these H2CO3 ions going on with no way of converting it back to CO2. Respiratory alkalosis is when you're hyperventilating. You've pushed out too much CO2, and you kind of see how that can be a problem. You're creating too much neutral solution, which you have some alkaline solutions in your body that kind of need that stuff. So, yeah, it's no bueno. We don't want to be losing too much CO2. We kind of want that carbonic acid and bicarb hanging out. It's a wonderful little buffer system that you really need, and if it's gone, uh-oh. You could also have metabolic acidosis and metabolic alkalosis. We talked about the lungs and we talked about kidneys. So if lungs has the respiratory alkalosis and acidosis, guess which one has the metabolic acidosis alkalosis? You got it. The main bad boy that's not having a good time is probably your kidneys. Metabolic acidosis, metabolic alkalosis. So when there are uh-ohs, so respiratory acidosis, it's not doing so good at releasing the CO2 because you're hyperventilating. You maybe got some pneumonia. Your muscles for breathing aren't working so hot. It's just not pushing out the CO2. The uh-ohs for respiratory alkalosis is, yeah, you're breathing, hyperventilating too much. You have some type of disease like asthma really trying to make you work at it, and you're releasing too much CO2, or you have a cerebral vascular accident that's sort of causing you to do too much breathing. And again, anxiety. So the results of it is this. How do you compensate? Well, you got two systems of excreting, right? You got your lungs that excrete out the carbon dioxide, or you have the kidneys that secrete out the hydrogen. So if you're not breathing so well, you're going to kick out that hydrogen. Problem is that, though, you're going to have a lot more of that HCO3, that buffer. And you got to remember that CO2 is being transported by hemoglobin, and that CO2 is still there hanging on, holding out with those hemoglobin molecules, which means it's kind of hard to move oxygen so well. So you got increased CO2 levels. Respiratory alkalosis is this. It's going to kick out less hydrogen. It's going to kick out more carbonate ions. So which means it's going to try and compensate for you for breathing too hard like a maniac. And it's doing a decent job, but your CO2 levels are going to be kind of low. Now let's talk about the reverse. Let's talk about if something's going on with your metabolism. Let's say that you're having diarrhea, maybe some kidney dysfunction, ketosis, you're not doing so well with, you're making a bunch of ketone bodies because your body is just not absorbing sugar, what have you. Those are all cases of metabolic acidosis. If you're doing metabolic alkalosis, is that you're losing acid from your blood and you're becoming too basic. Maybe you're throwing up, which means that you're losing a lot of your protons that way. Maybe you're peeing out a lot, like diuretics. This particular one in particular, this very particular diuretic, thiazide, is the one that causes this metabolic alkalosis you have to maintain, as well as an alkaline substances and drugs, like you're popping Tums like they're candy. Or you're taking drugs that have an alkaline substance that helps maintain its structural viability. How do you compensate for metabolic acidosis? Well, you hyperventilate. You're too acidic, you got to push more out. You're going to have low HCO3, and metabolic alkalosis, you're going to hypoventilate. You're going to try and retain some of that CO2, which then conversely gets converted into the bicarb or the carbonic acid. The problem is you're going to have high levels of HCO3. There's a handy dandy chart for you, respiratory, that refers to everything. This is probably a good point. If you want to, I'm going to go ahead and move forward. You can pause this video. I'm not going to stay there for forever. Again, aging sucks. It always sucks. Your metabolic rate goes down, your functionality, your kidneys go down, body surface area goes down, breathing rate kind of gets affected, and your iron concentration, iron withholding kind of sucks as well. So when you get those patients, make certain you are watching for them, making certain that they are A-OK. Thank you very much. I hope you have a wonderful and pleasant time again in pathophysiology. Miss you all. Have a wonderful time. And those of you that are new to the program, welcome to the program. Hope you enjoy yourselves.